students, good morning. Today we'll continue the nuclear fusion reaction. Okay, see the definition already you are well familiar. It is the process of combining two or more lighter nuclei to form a heavy nucleus along with the liberation of energy is said to be a nuclear fusion reaction. Okay, for example, when one hydrogen atom reacts with another hydrogen atom, gives deuterium, that is the isotope of hydrogen, and positron, neutrino, and large amount of energy. Is it? Say the hydrogen atom is the lighter element, it is the atomic number is 1, and when it reacts, it gives the deuterium. So the reaction between lighter elements and along with the formation of new element and energy is a nuclear fusion reaction. Similarly, when hydrogen atoms are combined, when the four hydrogen atoms are combined, there is a formation of helium along with the liberation of large amount of energy. Is it? See, while studying the nuclear instability, you have seen the graph. Where the binding energy per nucleon versus atomic mass number. Say you have seen this graph, isn't it? So here it is the iron. This graph is familiar to you. And hydrogen atomic number is 1, where hydrogen is having the binding energy per nucleon. Binding energy per nucleon is 1.1 millielectron volt, and that of helium it is 7.1 millielectron volt. See here, say the lighter element, that is the hydrogen, which is having very low binding energy, and the next to it is helium, which is having 7.1 millielectron volt, mega electron volt of energy. Is it? Say, as the binding energy per nucleon increases, and when such elements are made to react, the liberated energy is also increases. That means as the binding energy per nucleon of the lighter element increases, when they undergo nuclear fission reaction, then there will be an increase in liberated energy, and that is said to be a fusion reaction, energy of fusion reaction in those reactions. Okay, so now the lighter elements which are having lower binding energy, they are less stable compared to the elements of the say nuclei which are having higher binding energy per nucleon. Is it? So thereby in a nuclear fusion, lighter elements undergo combination to give the heavy nucleus. Okay, so now here the difficulty is the lighter nuclei means which are having lower energy, lower binding energy. That means say the kinetic energy or the energy content of the lighter element is very low. In order to make them to react, okay, there is a repulsion and between the two hydrogen atoms, because they are positively charged, the nucleus are positively charged parts. When they bring nearer and or to make them to react, it is very difficult, and it is possible only at very high temperature. That means when they are highly energetic, when they are highly say uh, containing kinetic energy, when they are containing very high kinetic energy, then only they react with the other and gives the new product. So in order to make them to react, so the temperature of about 10 raised to 7 to 10 raised to 9 Kelvin must be maintained, and also the pressure of about more than or several thousands of atmospheric pressure must be needed to conduct the reaction between lighter elements. Okay, so the temperature I have said, it is to initiate the reactions or to conduct such reactions, very high temperature is required. That is in the range of say 10 raised to 7 to 10 raised to 9. But it is very difficult to achieve on earth. But even then, with high security, with many different ways. See, they are scientists are trying to use this principle in, say, in preparation of hydrogen bomb. Okay. Yes, with this we go to the next say. When the hydrogen atoms are made to react, this much temperature range and this pressure must be maintained. But once the reaction is initiated, once the reaction is started, and that reaction will be self-sustained chain reaction, because there is a liberation of energy, and this energy will be utilized in undergoing other lighter elements to fuse with one another. Okay, to react with one another, this energy is utilized, but to initiate the reaction we need the very high temperature. So therefore, such reactions, once it is initiated, they are uncontrollable and they are said to be self-sustained chain reactions. It is found, and due to very high temperature and pressure, they are said to be thermonuclear reactions or temperature dependent reactions. See, once the reaction is initiated, tremendous amount of energy is liberated. Okay, so the amount of energy will be very high, will be very high. See, the such reactions to initiate, the energy or the high temperature is required, and that will be obtained by, say, either atom bomb or nuclear fission of either uranium 235 or plutonium 239. When such fissile materials are subjected to nuclear fission reaction, the amount of energy liberated can be able to initiate. That means the temperature of that energy, that heat energy, is in the range of 10 raised to 7 to 10 raised to 9, and that energy is able to start or the initiate the nuclear fusion reaction. Okay, so now the question is why the study of fusion reaction is needed. So the answer is, this explains the solar energy. This explains the study of, say, the solar or stellar energy. Is it? And the second one, it explains the basic principle of hydrogen bomb. Okay. So now with this, say the reactions which takes place in the sun. So there are stars. They can be explained on two principles, two types of reactions or the cycles are there. The first one is, say, proton-proton interaction, and the second one is carbon chain. So in proton-proton interaction, say here, these are the steps. Say the hydrogen atom reacts with the hydrogen atom, gives deuterium, positron, neutrino, and the energy is liberated. In the second step, this deuterium reacts with the hydrogen atom, gives isotope of helium. Once again, there is a energy is liberated. Third step, when the two such isotopes of helium reacts, gives helium 4 along with protons and large amount of energy. So the combined energy comes around 26.7 mega electron volt. Okay, so another way, so when all the steps are added, so the first step into 2, second step into 2, and on adding you will get this reaction. 4 hydrogen atoms gives helium, 2 positron, 2 neutrinos, gamma radiations, and large amount of energy, that is equal to this much, 26.7 mega electron volt. The same reactions in some other stars, that means the combination of 4 hydrogen atoms, can be explained through carbon cycle. So in carbon cycle, say the carbon 12 first reacts with hydrogen atom, gives nitrogen 13, and the nitrogen 13 is a isotope of nitrogen which is radioactive, undergoes a decay, gives carbon 13. That carbon 13 very active and combines with, say, hydrogen atom, gives nitrogen 14, and this nitrogen 14 combines with proton, gives oxygen 15, which is radioactive, undergoes once again disintegration, giving nitrogen 15. And this nitrogen 15 combines with the fourth hydrogen atom, gives carbon 12 and helium atom. So in each step, that means these steps involves emission of energy, and once again it comes nearly equal to 26.7. Okay, so now with this, say in the sun or stars, they contain about 90% of hydrogen and helium gas, and only 10% of the remaining elements. So with this, we'll move on to the little bit explanation regarding the hydrogen bomb. See, in the hydrogen bomb, usually deuterium and tritium are made to react. Yes, you have seen here how the deuterium is obtained. Say it is D, will denote it by D, that is okay 1H2, and tritium is 1H3. When they made to react, and there is a formation of say helium, and enormous amount of energy is released. So first, to get the hydrogen is made to react to get the deuterium or to get the tritium. So in order to make these hydrogen atoms to react, we need very high temperature, and that can be achieved by nuclear fission reaction. That means plutonium 239. Plutonium 239, when it is bombarded with a neutron, slow moving neutron, this plutonium undergoes nuclear fission reaction, and whatever the amount of energy liberated during this fission, it is utilized to initiate the reaction between hydrogen atoms or protons, and those will first convert into deuterium and tritium, and they are made to react to give finally helium and large amount of energy. So once the reaction is started, within a fraction of second, the whole reaction will be completed. That means with the liberation of very large amount of energy, that means at once there will be a blast. There will be a blast when there is a very huge amount of energy is liberated all of a sudden or within a fraction of second. So there will be a blast or explosion will take place. So this will be the principle behind hydrogen atom. Okay, so I think you are familiar or it is clear nuclear fission reaction and its definition, and why the lighter elements are combining and how they combine or under what conditions they combine. You are familiar, and they are, once they started, they are self-sustained chain reactions which are uncontrollable, and they are temperature dependent reactions, or they are said to be thermonuclear reactions, and they are exothermic in reaction. And the main purpose of nuclear fission reaction is to know or to study more regarding the solar energy or stellar energy. Stellar energy means energy from the stars. And next, say, to study the basic principles behind hydrogen bomb. Okay, so atomic bomb is different. Atomic bomb involves the nuclear fission reaction, and hydrogen bomb involves to initiate fission is required, but further there is a fusion reaction, and with the liberation of large amount of energy. Okay, so with this we will continue in the next class. See here the contents of the stars, that means composition: 90% of hydrogen and helium, 10% is other elements, and the reactions which takes place in sun or stars, say, can be explained basis of say proton-proton interaction or carbon cycle. Say in both the case there is a combination, that means the four hydrogen atoms are combining to give helium, but the way of reaction explained in the first is like this, in the second cycle is like this. In both the case, the amount of energy comes same, 26.7. Okay, so with this we'll continue in the next class. Suppose if you are having any doubts, please make it clear. Contact my number. Okay, thank you.